We can generalize this idea of keeping things simple using the term invariant. So an invariant is simply a condition that is guaranteed to be true while your code is running, assuming you haven't messed something up. So it's the list of all the things that you can rely on, all the truths. So an S list with a Sentinel node has at least the following invariants. It has more, but here's a few that are kind of interesting. One is that the Sentinel variable, the Sentinel reference, it always points to a Sentinel node. That's something you have that's guaranteed to be true. Another is that the first node in the list, if it exists, is always at sentinel.next. And in fact, this is an invariant that I explicitly wrote out in the code right here as a comment. Another one is that the size variable is always the total number of items that have been added in this case. And so what invariants are good for is it make it easier to reason about your code. You want to write a method that does something like, say, add last. Well, you know all of these facts. So you know, for example, that add last doesn't need to, worry. It doesn't have to worry about nulls, a null value at first. And it's also nice because it gives you a checklist of things that you can think about. That once your method's finished running, all of your invariants should be true. So for example, when we're trying to write add first, well, we need to, if we keep all those invariants in mind, it might help avoid bugs like this if we have them listed on a sheet of paper or who knows what. Now, some programmers actually do like writing out the invariants, having them in the code, maybe even explicitly stating them as comments throughout. And sometimes you just think about them implicitly, but I hope that you'll find the notion useful. So that's it for today. In the next lecture, we're going to go even deeper. We're going to fix a couple of limitations of the S list that we've come up with so far. For example, so far we can only hold integers, and if we look at the add last method, it's kind of slow. So we're going to tackle those two problems next time, and then we'll talk a little bit about an alternate way to build lists, which is based on arrays. So I'll see you then, and I hope you found this tour into the weird world of Sentinel nodes to be fun.